Now, if a point is not on the unit circle, we can't use our usual formula. Sine theta is just the y-coordinate, cosine theta is the x-coordinate, and so forth, because we're not on the unit circle anymore. But similar principles are involved. If this is our angle, and I tell you that some point, x comma y, is on the terminal side of that angle, we can still figure out the trig functions of that angle. Again, if we draw in this little triangle, this side is the y-coordinate, this side is the x-coordinate. The hypotenuse now is not 1, because it's not on the unit circle, but it is the radius of some circle. And from that we can figure out our trig functions. The sine theta is opposite over hypotenuse, that's y over r. Cosine theta is adjacent over hypotenuse, which is x over r. Tangent of theta is still opposite over adjacent, that's still just y over x, and the other three are reciprocals. Cosecant is r over y, secant is r over x, and cotangent is x over y. And this r, being the hypotenuse of a right triangle, we can say is equal to the square root of x squared plus y squared. So if I give you a problem like I say the point, say 5, -2, is on the terminal side of an angle. It's on the terminal side of an angle, and I want you to find the 6 trig functions of the angle. Then we can use these definitions to figure out what those are. R, our radius, is just the square root of the x-coordinate squared plus the y-coordinate squared. So r is root 29. And once we have r, then we can just write out what each of our 6 trig functions is. Sine of theta is the y component, or the y-coordinate over r, which rationalizes to -2 root 29 over 29. Cosine is the x-coordinate over r, which comes out to 5 root 29 over 29. See, I'm running out of space there. Tangent theta is just the y component over the x component, it's -2/5. Cosecant is the reciprocal of sine, it's minus root 29 over 2. Secant is the reciprocal of cosine, it's root 29 over 5. And cotangent is minus 5 over 2. So using these definitions, we can then find trig functions of an angle that pass through any given point, whether that point's on the unit circle or not. It's useful to consider what we know about trig functions and see which trig functions have what SIGN sign in which quadrant, whether they're positive or negative. We know that sine is related to the y-coordinate of the y-coordinate of points on the angle. So sine is positive wherever the y-coordinate is positive, so that's positive in quadrant 1 and 2, and sine is negative in quadrants 2 and 3. Cosine is related to the x-coordinate, so that's positive, and if sine and cosine are both positive, tangent is also positive. So in quadrant 1, all 3 of our trig functions are positive. Quadrant 2, the x-coordinate is negative, which means that the cosine is negative. And if sine's positive, cosine's negative, that means that tangent is also negative. So in quadrant 2, just sine is positive. In quadrant 3, the cosine, the x-coordinate's negative. And if sine and cosine are both negative, then tangent, since sine over cosine, is positive. In quadrant 3, tangent is positive. In quadrant 4, the x-coordinate's positive, so cosine is positive, tangent is negative. So cosine is the only one that's positive. And it's easy to remember this because you guys know that all science teachers are crazy. Yeah, I thought that's a fun way to remember it. We can use that to do some problems that we've already done, just we might have angles that are not necessarily first quadrant angles anymore. So for example, if I tell you that sine of theta is -2/5, and I tell you that cosine theta is positive, and I say use trig identities to find the other 5 trig functions. Well, if sine is negative, cosine is positive, that means that we're in quadrant 4. So that lets us know what SIGN sign we should attach to our answers. If we only knew that sine was minus 2/5, we wouldn't know if we were in quadrant 3 or 4, because sine is negative in both those quadrants. So from there, we can find cosine, because sine squared plus cosine squared is 1. So minus 2/5 squared is 4/25, plus cosine squared is 1. Subtract that over, we get that cosine theta is the square root of 21 over root 25, which is 5. We know that cosine is positive, so we take that positive square root. Tangent is equal to sine over cosine, so that's minus 2/5 over root 21 over 5, which is minus 2 over root 21. So tangent is minus 2 root 21 over 21. And then we can find the rest just by taking reciprocals. If cosine is root 21 over 5, then secant is 5 over root 21, which rationalizes to 5 root 21 over 21. Tangent, the reciprocal of tangent is cotangent, so this tells us that cotangent is minus root 21 over 2, and sine is minus 2/5, so cosecant is minus 5/2, and then we have all of our trig functions. We could also do basically the same problem just by drawing a triangle. Say I give you tangent theta is 2/3 and sine theta is positive. Then we know, because these are both positive, we know we're in quadrant 1. So then all our values are going to be positive. If tangent of theta is 2/3, you can draw a triangle. Theta, 2/3. By Pythagorean theorem, we can see that this side is the square root of 9 plus 4, which is root 13. And then we can just write down all of our trig functions by using that triangle. Sine theta is opposite over hypotenuse, so that's 2 over root 13, which is 2 root 13 over 13. Cosine theta is 3 over root 13, so that's 3 root 13 over 13. We already know tan theta is 2/3, so we've got that. And then we can take reciprocals. Cosecant theta is root 13 over 2. Secant theta is root 13 over 3. And cotangent theta is 3 over 2. And we can also use what are called reference angles to evaluate trig functions of angles that are related to the angles we know from quadrant 1, because I made you memorize them, when those angles are in different quadrants. If we have an angle that lands itself in quadrant 2, this is our angle, okay? But this angle that it makes to the x-axis, we call that theta prime. That's our reference angle, and that reference angle is a first quadrant angle. And if it's an angle that we know the trig functions of, we can figure out the trig functions of that angle kind of by comparison to that. In quadrant 3, if this is our angle, our reference angle is still that acute angle to the x-axis. If our angle is in quadrant 4, this is our angle, and the reference angle is this one right here. Okay, for example, if I wanted to find, if I asked you to find the 6 trig functions of 7 pi over 6. Right? 7 pi over 6, if we figure out where that's at, 7 pi over 6, well, 6 pi over 6 would be pi, so that's 6 pi over 6, 7 pi over 6 is right here. Okay, that whole thing is 7 pi over 6, and it's pi over 6 more than pi, so this acute angle right here is pi over 6. Now pi over 6 is an angle we know the trig functions of, it's out here. It hits the unit circle at some point over here. This hits the unit circle at some point over here. And these points, 2 points, are the same except for the sign, SIGN, that is attached to the x and y coordinates. So we can use what our trig functions of pi over 6 and then attach the correct sign, SIGN, from what we know about quadrant 3 angles. So the sine, SINE, of 7 pi over 6 is directly related to the sine of pi over 6. Sine of pi over 6, you should know, is 1/2, but in quadrant 3, the sine function is negative, so the sine of 7 pi over 6 is -1/2. Cosine of 7 pi over 6, find the cosine of 7 pi over 6, we figure out what's the cosine of pi over 6. Well, that's √3/2. But we know that cosine is positive, or is negative, sorry, in quadrant 3. So that becomes negative. Tangent, the tangent of pi over 6 is √3/3. And tangent is positive in quadrant 3, so that just stays as √3/3. And then we can find the other three, just by taking reciprocals. Cosecant would be -2. Secant would be -2√3/3, and cotangent would just be √3. So to find the trig function of an angle we don't know, an angle out in one of our other quadrants, you just figure out what the reference angle is, and as long as that reference angle is a trig function that we know, is an angle we know the trig functions of, then you can evaluate all the angles just by attaching the correct sign. Let's do one more example. Let's say I want you to find the 6 trig functions of 7 pi over 4. So the first step is we need to figure out what quadrant this is in. So we look at, is this close to pi or is this close to 2 pi? Well, 2 pi would be 8 pi over 4, so this is pretty close to 2 pi, and it's pi over 4 less than 2 pi, so that means we're over here in quadrant 4. This is our reference angle, and that angle is pi over 4. So it's pi over 4 reference angle in quadrant 4. So we can figure out all of our trig functions. Sine of pi over 4 is √2/2, and sine is negative in quadrant 4. Cosine of pi over 4 is also √2/2, but cosine is positive in quadrant 4. Tangent of pi over 4 is 1, but tangent is negative in quadrant 4, so we attach a negative sign, and then we can get the other 3, as we always do, just by taking reciprocals. That's minus root. Both of these are going to be √2. Cosecant will be minus √2, secant will be positive √2, and cotangent will be -1. So once we figure out what our reference angle is and what quadrant we're in, we can use the values of the values of the trig functions of the reference angle to find trig functions of angles that are not in the first quadrant.